So here's a couple example problems from 4 day 2. Um, so as you can see, example 1, we simply have a fraction divided by, hope you guys can see that, it's not plus, fraction divided by 8/9. Remember the rules. The first fraction stays the same. The division turns into multiplication, and then you flip the second fraction, and then you multiply. And don't forget what I've taught you a few times. When you multiply fractions, cross-reduce, swoosh. Cross-reduce means 3 goes into 3 once, goes into 9 3 times, 2 goes into 2 once, 8 4 times. What is this swoosh thing? Just multiply the top, multiply the bottom. So I get 3/4. Now why do I have this thing written like this? Well, I need you to know, because your homework problems are going to look like this. These are called complex fractions. It's going to have a fraction in the top and a fraction in the bottom. But I need you to kind of see through the complexity of it and see it as what it is. It's really the top divided by the bottom, which is no different than this. So really what I'm trying to say to you is we're going to multiply the top by the reciprocal of the bottom. Here's the problem. It's a mess. So I need to give you this huge clue. Taught driver's ed for a long time. And one thing you need to know is if it's a double white line, I know one's purple, one's red, but imagine double white line, don't you dare cross that. Illegal. And I kind of want you to think of it that way. Because what we have is problem number 1 in the top, problem number 2 in the bottom, and then we really have a division bar right there, which is problem number 3. So let's attack this one piece at a time. Now these can get a lot harder than the one I'm about to show you. But if we take a look at the top, we have 1 over x plus 2 over x plus 1. Now, this is different than this. So I know, whoops, I'm not going to put a 1 there. My common denominator is going to be this times this. It's like that's a 2 and that's a 3. So it'd be 6. But I don't know what x is, so I have to represent the 6 using good old algebra. And now I ask myself the question, what do I got to multiply this by to get this? That'd be x plus 1. Then I'd have to do the same thing to the top. So anything times 1 is just itself. Now what do I got to multiply x plus 1 by to get this? Well, that would be times x. So I got to show my work so my brain doesn't malfunction. So I get 2x all over my common denominator. And now I've got common denominators so I can add like terms in the numerator. So 2x plus x is 3x plus 1 all over x times x plus 1. Now here it comes. This is all over 1 over y. Now here's the thing. I said problem number 2 is this. Good news, there's nothing to do. Bad news, I have a third problem I need to do because I need to take the denominator, just like I did here, and multiply by the reciprocal. So I need to go, aha, this is the same thing as, let me pause this a second. Something seems fishy. I thought maybe I copied this down wrong and that should be an x, but it's not. There's going to be a mix. I thought maybe the x would be in there so things could cancel later, but it's a y. So we got to take this guy and think of it this way. This divided by this is the same thing as writing it like this. And then we should be able to go, wait a minute, I get it. So that's 3x plus 1 all over x times x plus 1 times, remember you change the division of times and then you flip this, y over 1. Now how exactly they want us to write this, I'm not sure. But I'm going to write it as 3xy plus y all over x times x plus 1. Now the thing I'm saying is maybe they would write it like y times 3x plus 1 and just leave it like that. Either way is fine, but I bet you this is what they did. All right, I'm going to pause that a second. There's another one, similar but different. Similar because you have a fraction divided by, now you don't literally need to make a double line there, but it helps me. So I'm like, okay, I can't cross that. In other words, don't let this thing dip down beneath there. Anyways, just think of it as problem number 1 in the top, which by the way, there's nothing to do. It's just one fraction. Can't simplify that. Now this time, it's the denominator that's going to be a mess. I got to find common denominators there. And then problem number 3 is this division bar. We'll take care of that later. Problem number 1, we don't have anything to do. 2, we got to find common denominators. So here it comes. X plus 1 over 3 plus 4 over x minus 1. What's our common denominator going to be? This times this. 3 times x minus 1. 3 times x minus 1. Ask yourself, what do I got to multiply this by to get this? That'd be x minus 1. But if I do it down there, I got to do it up there. A little bit of difficulty here. So x times x is x squared. Outside is x. Inside is negative x. Last is negative 1. These middle things cancel, so I'm left with x squared minus 1. What do I have to multiply this by to get this? That'd be a 3. I'm going to multiply that by a 3. Well, 4 times 3 is 12. So look for like terms in your numerators. I don't have any, so it's, well, I got the constants. X squared plus 11 all over 3 times x minus 1. That is the answer to the bottom. So this problem literally just turned into 1 over x minus 1 over x squared plus 11 over 3 times x minus 1. If you can remember, if I have a fraction divided by a fraction, I got to take the second one, or the one in the denominator, flip it, and multiply. And now that I've done that, I think to myself, okay, when I multiply fractions, I cross-reduced and swoosh. Looks like this got tweaked a little bit there. Sorry about that. And so now I think, aha, here's an x minus 1. I'll put it in parentheses. And then that's it. So now I swoosh. 1 times 3 is 3. And this is just what's left in the denominator. There's nothing you can do with that. All right. So yeah, there'll be a couple problems like this on your homework. Simplify the top if you can. Simplify the bottom. Multiply the top answer by the reciprocal of the bottom answer because that's division. One more little sample problem that's more of a story problem thing. Story problem number 2. The first one's from the pre-lesson. This one's similar, but a little subtle differences. It's still built off this formula where time equals distance divided by rate. So we're going to piggyback this formula and try to take a look at this. Frank is traveling to a park. He walks, see there's one way to move, 2 miles to the bus stop. So we know our situation number 1, he walks 2 miles to the bus stop. The distance is 2, and he's walking a certain rate. We're going to let that be our R. He rides a bus for 5 miles at an average speed that's 10 times as fast as he walked. So we take, all right, situation number 2, he rode a bus for 5 miles, but he was 10 times as fast in the bus, so that would be 10R. Now, think about this for a second. If we just keep moving, we won't notice something. 5/10 can reduce to 1/2. So I'm going to use this. It's easier to use than that. So look for those opportunities to reduce whenever they present themselves. Then it says, he then walks 1 more mile at the same speed as he did before. So that's like, okay, in the walking phase, it's 1 mile over R. Notice we've got common denominators, so it'd be 3 miles at the same speed. So this is the time he takes walking. This is the time he takes in the bus. And the question is, write the expression for the total time this trip takes. Well, that'd be 1 over 2r, time you spent on the bus, plus 3 over r, the time he spent walking. Got to find common denominators. If this is 2, one way to look at, I don't want to make this overly complex, but if we stick with just the 2 and the 1, we think, okay, what's the common denominator going to contain? It's definitely going to have a 2. Now we have an r here and an r here. Some students think, oh, that's going to be r squared. No, 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 no. You want to find what's common. You see, there's an r common, and there's an r common. You take what's in common. Don't overthink that. So what times this gives me 2r? 1. So that means this doesn't change. What times this gives me 2r? Well, I have to multiply that by 2. That means I got to multiply the top by 2. So that'd be 6. 6 over 2r plus 1 over 2r is 7 over 2r. And that is the expression that'll represent the time a trip takes based on their walking rate, okay? Because that's what we set r equal to originally. There you go. And that's all they want for this question. So that ends your example problems from 4-4 day 2.